complicated problem. There might be other ways to do part B, but I'll show you one way. Here's your function, which is this red graph right here. And we're asked to find the equation of the normal, which is perpendicular to the tangent line. Okay, so we're at the point where x equals a. So this is a general formula. So if a is the x coordinate, then f of a is the y coordinate of the point of tangency, or a comma e to the 2a. And if we find f prime of x, that's 2e to the 2x. So f prime of a, the slope of the tangent line, is this, 2e to the 2a. But we want the slope of the normal line, which will be the negative reciprocal. So that's what this is right here, the negative reciprocal of the slope of the tangent line. Here's point slope. There's the y coordinate of the point of tangency. There's the x coordinate of the point of tangency. To get this answer right here, we're going to distribute this slope, the slope of the normal line, over both terms of x minus a, and then add e to the 2a to both sides. So there is indeed the equation of this normal line right here for any value of a. This equation will be the equation of a line that's perpendicular to the tangent line at the point where x equals a. Now we're looking for part B for the specific normal line that passes through 0, 0. So if you slide this point down to here, it'll eventually go through 0, 0. And if it goes through 0, 0, that means that the x value for the tangent, this normal line, will be 0, and so will the y value. And so here's what we've got. If we put 0 in for this x, this term disappears. This term is a 0, and this is the equation we end up with. If we multiply through by 2e to the 2a, we get a plus 2e to the 4a equals 0, and the question is, what value of a makes this true? And here's where you could use a graphing calculator, or you could use Newton's method, which is what I've done over here. I've set up this function f of x equals x plus 2e to the 4x. I want to know, when does this equal 0 using Newton's method. Here's a formula for Newton's method, where x is initially the initial value we start with. I used negative 0.4 after looking at the graph. And then here's subsequent invocations of Newton's method. And this looks like the value of a that's going to set this equal to 0. And here I used a capital A just so we don't confuse it with little a. That's this value right here. And if I substitute that in for the little a in this original equation, here's what happens. E to the 2a, this term right here, is 0.448. This term right here, negative 1 over 2e to the 2a, this right here, is negative 1.116, blah, blah, blah. And this term right here is a over 2e to the 2a, which I wrote as f prime of a, is negative 0.44. Well, these two terms cancel out. So that's the slope of the normal line. And that means these two terms canceled out. So the equation of the normal line that passes through 0, 0 is y equals this value right here times x. And that's why your answer is negative 1.12x. Okay, again, there's other ways to find the value of a that make this equation true, but Newton's method's a good one. There you go. Hope that helped. If you have any questions, post a comment.